Okay, guys, so we have spent a little bit of time right now getting into linear expressions. Now we're going to go into deeper detail and do some other things with them. Yesterday, right, we were adding linear expressions. Today, we're going to be talking about subtracting them. All right, and while it's similar in some ways, it actually changes in others. Okay, so we're going to take linear expressions and subtract them. So make sure most of you guys already have your paper out. Make sure your paper's out. Name up at the top, right? Name, period, date, all those good things. Assignment number, book page. Okay. No vocabulary on this because you guys already know what linear expressions are, and I think you know what subtracting is. All right, so here we go. Okay, so what I want to do is, and the little thing in the parentheses, a little note to me, but I actually had remembered already. Anyway, let's go ahead and let's take a look at page 312, and let's take a look at problem number 3. All right, problem number 3. So on number 3, the directions just say subtract, use models if needed. So we have two linear expressions. We have 9x minus 4. And the other expression is a negative 2x plus 1. And we are subtracting them. Okay, now, like we said in the lesson yesterday, okay, or like the lesson was saying yesterday, is that what we have is realistically, if you're to look at both of these, what's really missing is it's almost like a 1 is missing in front of them. Now, yesterday, right, this was a positive, so it ended up being positive 1. And realistically, value-wise, if a 1 is on the outside, you're going to multiply that with both terms on the inside. Okay. Now, the thing about that is we now know, all right, as 7th graders, that if you multiply anything by a positive 1, you're going to get the same thing. So what that allowed us to do was yesterday is basically drop the parentheses, ignore the parentheses. That is what happened yesterday. Now, if you go about doing the exact same thing, of course, 1 times 9x would be 9x. 1 times a negative 4 is negative 4, right? Minus 4. So it would not change anything, but there's an issue here. If we put a 1 here, it does change some things. And if you don't believe me, then we're going to do it. So here we go. Step 1 is squeeze a 1 in there. Okay? Now, you don't necessarily need to squeeze a 1 up front because, again, that's a positive 1. This subtraction sign, though, when we squeeze the 1 in there, it becomes a negative 1, which means step 2 is we're going to need to do distributive property on the second linear expression. So we have a negative 1, a negative 2x, and a positive 1. Negative 1 times negative 2 is a positive 2, of course, with x. And a negative 1 times a positive 1 is a negative 1. Now, after we do distributive property with that second one, because of the subtraction sign, now the first is just like yesterday. We can ignore these or just drop the parentheses. 9x minus 4. From here, we're going to go ahead and we're going to combine like terms. So, here's a 9x. My other x term is a positive 2x. This negative 4 is a constant. I'm going to circle it. And the other constant is negative 1. So combining my boxes, 9x plus 2x gives us 11x. Combining my circles, negative 4 minus 1 gives me a negative 5. There are no parentheses. There's no like terms. That is our simplified answer. Now, some of our minds look for quicker ways to do things, or patterns, or things that just we can discover. Now, there is something that -1, the bottom line is that -1 or that subtraction sign in front, how it really changed everything inside the parentheses. Does anyone, any brave soul in here want to give me what happened to everything, both terms inside the parentheses from here to after when we did the distributive property?
Every negative was turned into a positive and every positive turned into a negative.
You guys hear that? Every negative term became a positive term. Every positive term became a negative term. So, if you don't understand that, that's okay. These are legitimate steps that will get you the right answer. However, bless you. If you would like to, you can do your homework this way, and I'm okay with it. Here we go. The first of all, step 1, or we can even say step star is crucial. This only works if there's a subtraction sign here. Positive sign, meaning adding linear expressions like yesterday, drop parentheses and simplify, okay, combine like terms. Today though, negative, completely different story. You cannot just drop the parentheses because of this. So here's what we're going to do. If it's subtraction, we move on to step 1, and that is we can go ahead, write the expression from the first expression by dropping parentheses. Step 2, because of the subtraction sign, all you need to do is rewrite the second term by changing all negative terms to positive and all positive terms to negative. So this subtraction sign here would change the negative 2x to a positive 2x and the positive 1 to a negative 1. Now, one of the questions people say is, Mr. Wilkins, but that's a double negative. Can't they just do this? Yes. The issue with that, though, is you're only changing the front sign. That one also changes because of distributive property. So you have to be careful. That's the first mistake some people make. Oh, double negative. I'm going to turn it into a big positive sign. I'm good to go. No. You have that negative is distributed throughout the whole set of parentheses. That's why. Okay? So make sure you change both signs. And now, of course, step 3 is combine like terms, which was step 4 here. And from here, right, we do exactly the same thing that we did before, and we still get our 11x minus 5. So what I'm getting at is that bottom line is the -1 affects everything in the parentheses. If you realize that, then all you have to do is rewrite the second expression by changing all signs in the parentheses on the second expression, okay, with that subtraction sign in front, and combine like terms. Okay? Any questions about that? A negative and a positive if you're multiplying, you're saying? Adding, you use a t-chart. If you're not sure how to add integers and not sure of that yet, use your t-chart. Okay? The rule you're talking about is multiplication and division, I believe. Would you say negative times a positive is a negative? Is that what you said? Okay. All right, guys. Any other questions? Okay, here's one I want you guys to try. Number 11. Number 11. Try that out. Go. Anyone need more time on that one? Okay. All right. So 30 seconds. Go ahead, turn to your neighbor and share. Go.
I got negative x plus 2. I did the English one. Is it negative 1 times positive 2?
Oh, yeah.
Bless you. All right, here we go. For right now, just want an answer. All right, just want the solution to the simplified answer there. C, no, not here. C28. Negative x minus 2. Agree, disagree. Negative x minus 2. Okay, let's get some other answers that could be out there. All right, C25. 25. That is you.
I got negative 1x plus 2.
Negative 1x plus 2 or negative x plus 2. Agree, disagree with that one. Okay. Okay, anyone have something different? Okay. All right. Well, let's take a look. So, subtraction, first thing I notice, subtraction of two linear expressions. That means I can drop the parentheses to the first because it's all positive anyway. And then here I'm going to change the signs inside the parentheses. So the positive 2x becomes a negative 2x. Positive 3 becomes a negative 3 or a minus 3. Go ahead, combining like terms. Okay, I have my x or 1x minus 2x, and I have my two constants, a positive 3 and a negative 3. So x1 minus 2 basically is a negative 1x, or just negative x. Positive 5 minus 3 is a positive 2. And there's our answer. Which a majority of you guys got that. So, all right, questions? No, it's same value. You want to try to get rid of the 1 because that's not usually how you'll see it in problems. But it's like one of those things. Like if you see, if you see a decimal point written like that, there's probably a 0 there. If you see something like a 6, that's a positive 6, even though you don't write it. Okay, so the same kind of thing. Even though there's no 1 there, you can know that there's a 1. But no, it's the same value. You'd be okay. All right, Dina, was that your question?
Yeah.
Okay. Any other questions, guys? All right, let's try one more together. Here we go. Let's take a look at problem number 5. Number 5. So it says, let's close, read the directions here. Here we go. Number 5. The cost of an item that weighs X pounds from Charlotte to Chicago is shown in the table. All right, so you have the shipping company, the cost for each shipping company. Let's go ahead and take a look at 5. We'll start off with the A part. It says, write an expression to represent how much more Atlas charges than Mid-Atlantic for shipping an item. Now, I just had this talk with my last class, all right, my Math 7 class. And this is such a powerful tool when you're dealing with fractions, decimals, things that you might get confused on when it comes to a word problem, and that is solve a simpler problem. Okay, so if you take a look, right, you have the two prices. This is like price 1 and price 2, or company 1, company 2. This price is 4x plus 280. this is 3x plus 125. Now, solving a simpler problem means get rid of, just make it easy. So listen, if it says, write an expression represent how much more Atlas charges than Mid-Atlantic, how much more Atlas charges, which is the top one, that means that this would charge more. If it says how much more, well guys, if Atlas charged $2, or let's say $3, and Mid-Atlantic charged $1, how much more would Atlas charge in Mid-Atlantic? $2. Now listen, I don't care about the answer. What I care about is how did you get the answer? What'd you do? Which operation? Subtraction. Now just because you have this expression here does not mean that you change the process. It's exactly the same operation. So instead of 3 minus 1 doing a, first or second grade word problem, we're going to do a 7th grade word problem. It is still this minus this. So here's how you do it. If you're going to write steps, okay, I would say step 1. I'll just put simpler problem, okay, and you can put like a little brain here if you want, all right, for step 1, because it's basically mental math. Throw a couple numbers in there, check it out. Okay, step 2 is, of course, write your expression. So in this case, it's this minus this, right? Well, it's 4x plus 280. Now be very careful because as soon as I put my subtraction sign in there, I need to make sure that I put parentheses because this is one value. This represents another value. Okay, two different linear expressions. Make sure you have your parentheses around it. If you don't put your parentheses, it just looks like minus 3x plus 125, and then you won't bother to change any of the signs. Okay, but that wouldn't be right. Now, of course, after we write our expressions, then the last part is simplify. So, of course, simplifying is doing everything we did up above. So, when I do this, here we go. 4x plus 280, which I could just drop parentheses because it's all positive. However, this is a subtraction sign. So, I'm going to change all the signs inside the parentheses. So, it becomes a negative 3x minus 125. Okay, so I go ahead, combine like terms. I have 4x minus 3x, and then I have, even though they are decimals, they're still my constants because they're just numbers. So 4x minus 3x is a positive 1x, or just x. Okay, most of you guys probably can do this one in your head, but 280 minus 125 equals 155. It's a positive 1.55. And that is our simplified expression. Okay, now, just like yesterday, B takes it a step further, right? You have your expression, what it would represent, the difference is that much. Okay, but it says, if an item weighs 2 pounds, how much more does Atlas charge for shipping it? So all you're doing is, because if you read in directions, X is the amount of pounds, we take our expression and we simplify the expression by plugging in the number. So it says X is 2 pounds, so I'm going to go ahead and use parentheses, plug in my 2, plus 155. If you want to count that as a step, plug in your number, use parentheses. And step 2 is simplify, which mental math for us, right? 3.55. And of course, step 3 is make sure there's units on it. As a matter of fact, a lot of times on here you will see units on an expression too. It looks kind of weird, but that is just representing the value, a simplified value. Okay, word problems, questions? Okay. All right, the problem I want you guys to try out is problem 12. Problem 12, try that out. Go. How many of you still need more time? Okay. All right. Checking with you guys in about another 30 seconds. Okay, checking in. How many of you still need more time? Okay, give you a bit more. Those of you that are finished, you can go ahead and that's it for our lesson. So you can work on some of your homework while we're waiting. Remember, guys, if you're struggling during this time, that's okay. Use your notes as a resource right now. Use your notes. Okay, how many of you still need more time? Okay, 30 seconds. Okay, go ahead, share both of your answers to problem 12 for A and B both, all right? So 30 seconds, go.
For A, I got negative 4.5 plus 2.
That's right, but B I didn't.
For number B, I got 33 miles.
Okay. Some good math discussions going on. Let's kind of regroup as a class here. All right, let's check it out. Just want some answers. All right. So A. So just looking for the A answer. Okay. Seat 6.
I got negative 4.5 plus 2.
Negative 12 point.
No, 4.
Oh, 4.5.
Yeah.
Sorry, my fault. Negative 4.5. I'm getting old. My hearing's going. Negative 4.5
Plus 2.
plus 2. All right. Agree, disagree? Okay. Anyone else want to share?
I got 4.5x minus 2.
Positive 4.5?
Yeah, positive.
X plus 2?
Minus 2.
Or, oops, minus 2. Agree, disagree with that one? Okay. Any others out there? Okay. Now, first of all, we have to pay close attention to some details here. Okay? That expression would be incorrect. Because that expression, here's why I know it's incorrect. It's not simplified. Remember, simplified means there's no parentheses and there's no like terms. Are those like terms? Yes. Absolutely. So something is incorrect there. My guess is, you know, in the problem, right? That's kind of what I'm thinking. Okay. So those of you that either said that or agreed with it, because there was a chunk of you guys. You have to be careful of stuff like that. It's very easy, especially when you're doing distributive property and you're multiplying. You get so wrapped up in the coefficients or the numbers that you forget the variable. All right, it's a simple, common mistake, but you've got to be careful, because I had it up here the other day. Did we talk about this in class? 7 means this. 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Did we talk about that? 7D is this. D plus D plus D plus D plus D plus D plus D. If you leave the variable off, you have a complete different meaning. These are 7 1s, like since you've been going to school. However, now you talk about variables, these are 7 Ds. Okay? So 4.5 or even negative 4.5 and negative 4.5x, completely two different things for that reason. So be very careful. I know it seems such like a little thing, but it's really big. Okay? All right. So we'll take a look at this right now. So here we go. Number 12a. It says the expression 5.5x plus 2 represents the number of miles Celeste rode her bike, and 10x represents the number of miles that Kimiko rode her bike in x hours. Okay? So x is obviously hours. It says write an expression to show how many more miles Kimiko rode than Celeste. All right? So the way that's worded, right? How many more miles did Kimiko ride than Celeste? It's implying that Kimiko rode more miles. All right? So meaning that would be the larger number. And because we were finding the difference between the two, we'd put the larger number, when given a choice, we'd put the larger number up front. So what that means is I would have What that means is I would have 10x. Oops, sitting there right on B. 10x is Kimiko's, and we can put parentheses around it if we want. And then it says Celeste rode her bike 5.5x plus 2. So 5 and 5/10 x plus 2. I want to make sure I'm writing that correctly. Now remember, they want to know how much more, meaning, of course, if this was 10 and this was 5, you'd say, oh, it's 10 minus 5. So that's basically what we're talking about. Now to do this, right, we have 10x. We just drop the parentheses. This subtraction sign here in front of this linear expression, I'm going to go ahead and change the signs in the parentheses. So instead of positive 5.5, it's negative 5.5x. Instead of positive 2, it's negative 2. So I take a look. I'm now ready to combine like terms. There's my x term. Here's my x term. Here's a constant. So I'm going to go ahead, subtract my coefficients. 10 minus 5.5 equals, and I get positive 4.5. Don't forget our x. And then there's nothing to combine the negative 2 with. I just bring it down as minus 2. And there's our answer. Okay, before we go on to B, because I know some people had this part. Any questions? I'm looking, right? And I'm saying, oh, and this could be, there could be a couple of different ways you can get this, but I'm looking at the signs being different, okay? You just got to be careful with that, okay? Any questions? So I'm assuming if there's no questions, then we know exactly what we did wrong, right? Make the mental note. Make sure you fix it whenever you get going on your homework, all right? Don't keep doing the same thing over and over again if it's wrong. All right, let's try B. I'm just going to go ahead and finish off B. We have our expression, right? 4.5x minus 2. Remember, you got to keep an eye on what the x represents, and it says in that part, x is the amount of hours, okay? So it says, B says, if they rode for 2 hours, how many more miles did Kimiko ride? So all they're saying is plug 2 in for x. And if I go ahead and use order of operations, I have to do the multiplication first. That's basically 4.5 times 2, which gives us 9. Rewrite my problem. 9 minus 2 gives me 7. And because this is a word problem, 7 hours.
Is it in miles?
Oh. Oh, yeah, sorry. Thank you. Good call. X is the hours, but when you plug it in, yeah, you're looking for miles. Okay. How many more miles did Kimiko write? Okay. Questions? Okay. The reason why I did that and didn't get, because more than likely whoever used this got a different answer than whoever used this, right? So that's why I just figured I'd do it with the correct expression. Okay, so subtracting linear expressions.